This is the first of two videos about logarithms. In the first video, this one, I'll derive a few of the really key and important properties of logarithms. And then in the second video, I'll show you how you can use these logarithms to solve certain types of problems. So let's start by going back to the definition of a logarithm. A logarithm undoes exponentiation. So I think of this as the defining relationship for a log. What's log x? Well, log x is a number which, if you put it in the exponent for base 10, happens to give you x back. So this means that logarithming and exponentiating undo each other. They're inverses of each other. We could also write it this way. Log of 10 to the x is x. So it doesn't matter what order you do them, you exponentiate and then log, you log and then exponentiate. In both cases, they undo each other, they cancel, and they get back to, you get back to where you started. So logarithms are sort of a type of exponent. And so properties of logarithms follow from properties of exponents. So I want to start, I'm going to do two properties. And for each one, I'll begin by talking about the exponent property, and then we'll use that exponent property to derive one of the log properties. So let's start with an exponent property. What if we have something like this, 10 to the a times 10 to the b? What does that equal? Well, you might remember that if you have two exponents multiplied together like this, or two quantities multiplied together like this, with the same base, that you just add what's upstairs. So 10 to the a times 10 to the b equals 10 to the a plus b. And this follows just from the definition of an exponent. An exponent is successive multiplication. 10 to the a means multiply 10 by itself a times. So let's convince ourselves that this is true by doing an example just with numbers. So suppose we have 10 squared times 10 cubed. Well, let's see, what's 10 squared? 10 squared is 10 times 10. Multiply it by itself twice. What about 10 cubed? Well, that's 10 times 10 times 10. 10 times 10 times 10. So now we have 5 tens here together, and that makes sense. Multiply, we've got 2 tens and 3 tens, they add together, and it's 5 tens. So this little example is designed to convince you that this is true. It has to be true. How could it be anything else? It just follows from what exponents are. So now let's use, we're going to use this property and in the context of logs, and we'll derive a log property. So let's see. There are a lot of ways to do this. Here's how I did this. All right, so now we'll do this with logs. I'm going to use this with some logarithms. So suppose I have 10 to the log AB. Well, as I said before, exponents and logs, they cancel each other. They undo each other. So 10 to the log AB is just AB. That's just the definition of a log, but instead of x, I have two numbers, AB, whatever AB is. So now I'm going to write A as 10 to the log A, and B as 10 to the log B. And why can I do this? Well, again, I'm just using the definition of a log. A is 10 to the log A. Right? These two just undo each other. And B is 10 to the log B. So I can just do that substitution. A is 10 log A, B is 10 log B. And aha, now I've got two exponents with the same base, so I can add them together just like I did here. So let me do that. I'm going to run out of room, so let me put it down here. 10 log A plus log B. So now let's look at what we have. We've got 10 to the log AB equals 10 to the log A plus log B. So it must be that these two terms are equal. If 10 to the something equals 10 to the something else, then the something and the something else have to be equal. So that means that log AB, the log of a product of two numbers, is the same as the log of the first number plus the log of the second number. And this is one of those famous and useful properties of logs. It's certainly good to remember, but I don't think you should have to memorize it, in the sense that you just remember that this follows from this exponent property. Maybe it's a little bit less mysterious where this comes from. So this is the first property of logarithms that I'll talk about. So to derive another property of logarithms, we'll start with another property of exponents. And that is that if we have, say, 10 to the A to the B, that's the same as 10 times A times B. So when you have an exponent to the exponent, you can multiply those together. And again, we can convince ourselves of that by just trying out an example with numbers. So 10 squared and then cubed. Well, let's see. So 10 squared is 10 times 10. And then we need to cube 10 times 10. So that's this thing in parentheses 3 times. I guess I'll keep the parentheses to make that clearer. 1, 2, 3. And so we have 1, 2, 3, 4, 5, 6. 6 tens. So this is 10 to the 6th. 2 times 3 is 6. 2, 3 times. All right. So this property of exponents, that follows, again, just from what exponents are. Exponents mean successive multiplication. So now let's do something like this, but with logs, as we did before. So I'm going to start with this relationship. A equals 10 to the log A. That's just the definition of a log. If you start with A, you log it, and then you exponentiate it, you're back to where you started from, because logs and exponents are inverses of each other. They undo each other. Now, let me take both sides of this equation and raise it to the p power. And then we have 10 to a number to a number. Remember, log A is just a number. So that's like 10 to the 2 to the 3. So that means we would multiply those together. So this is actually the same thing as 10 to the p log A. So p and log A are multiplied together now. But I can do something else with A of p. A of p, sorry, it's a messed up p, but you get the idea, is just log, is 10 to the log a to the p. So let's just look at this line. Again, this is just the definition of a log. A to the p, blah, is just 10 to the log blah, because we start with a to the p, we log it, we exponentiate it, that undoes each other. So again, this is just the definition of a log, what a log is, applied to this funny number a to the p. But now, a to the p equals both of these things. So both of these things have to be equal. So this tells me that log AP is P log a. So this is the other property of logarithms that I wanted to derive, show you where it comes from. You don't need to be able to repeat these derivations, but I hope they're logical, provide some comfort, knowing that this property of logs, which is super useful, as we'll see in the next video, doesn't come from thin air. Each property of logs, this one or the one I did before, comes from a relatively simple property of exponents. So in the next video, we'll use these properties to solve some problems.